All right. So we just finished talking about and visiting Mercury, and we escaped with our lives, which is good because it was 800 some degrees. So we are now going to head to our next destination, which is going to be Venus. So we advance to Venus. Welcome. Go ahead and write the hot planet down.
How is this the hot planet?
You'll find out soon. There's some spare pencils in the back if you need them. So Venus is the hot planet. A little bit about the history of Venus here. Go ahead and write down the first and second bullet point. Not the third. She's actually not my type. Too much makeup.
Are you talking about
That's a she?
Yes, that's a she. We're off to a blazing start here. What do you think she's saying to the bird there?
She's singing to it like that one princess.
Oh, she's singing. Okay. That
Yeah,
could be
I told
it.
you I could do a push-up on one arm.
Maybe she's like, in her.
It's the bird part of the song now.
Okay. So the thing is, Venus is a little bit closer to the sun than the Earth is. So in the past, people saw it moving through the sky, and they thought this could be just a nice, wonderful tropical paradise. Maybe just an everlasting summer vacation or something. It turns out it's just about the opposite of that. If you picture Venus, it looks a lot more like this. So, yeah, not exactly your typical tropical paradise. Not one that I'd pay to go to anyway. In terms of the surface here, though, at least the surface is solid. It's something you can walk on, but you cannot see it through the clouds because Venus has a very thick atmosphere. Go ahead and write down surface and that it's terrestrial, cratered, and rocky. You can skip the first bullet point there. Once you finish these two bullet points, just go ahead and make a note that people did used to think it was a tropical paradise. Yeah. People used to think it was a tropical paradise. So this is the sort of thing you would see from the surface, and this is a pretty good representation of what the sky would look like too. It's going to be an orangish, yellowish color there, and you would see some lightning, as we'll talk about in a little while. So when we take a look at Venus's surface, most of it is shaped by volcanic activity. This picture, along with a lot of the others you're going to see as we explore Venus, are taken by using like a sonar type of technology. You have a satellite that's going around and around the planet Venus, and the sonar penetrates through the clouds, and it allows us to create a 3D map of what the surface looks like. On these pictures, the brighter colors represent hotter temperatures, so you can tell this is probably a bubbling volcano. This is a real picture of the surface of Venus. And one more right here. This is a true color image. These spacecraft that made it down to Venus's surface only lasted for a little while. You'll find out exactly why that is, but Venus is very hostile to anything living or not living. So it also has plains. You can see it's a lot of flat land here. We've got some lava flows. These are probably coming from that larger mountain in the background there. Mountains, craters, rift valleys. Now this right here, just like in Mercury we looked at the Caloris Basin, some giant feature that's present on that planet. This is the one we're going to look at for Venus. Go ahead and write this whole slide down. It's the longest one we know of. Bigger than anything we've got on Earth.
How long is
That's a good question. I'd guess maybe 1,200 miles would be my guess. So this is a very large channel. When we've observed it right now, it's not actively flowing anymore, but we can see the remnants of things that used to be flowing. And it was a lava flow is what it was. It wasn't water or something like that. But it is one of the more interesting features we found on Venus. So again, these images were taken using sonar, looking through the clouds. So this is, a spot where the channel begins, and it follows along here. You can see it going down, and it curves up right here. And you kind of got to get close in order to see it continuing, but it goes there, comes up and around, and it kind of goes off the screen over there. So this is one massive, massive channel. There is no liquid on Venus aside from the lava that's flowing over not a lot of it, but a fair amount of the planet has lava on it. But if we did map it out, and if there was like water on it like there is on Earth, this is what the map of Venus would look like. You would have some highlands up here, and some really, really tall mountains in that area. And in the bottom east over here, you'd have another one. So that's just about what the topography of Venus looks like. You don't have to write these down or anything. You can do this one, though. Venus spins awfully slowly, just like Mercury does. So in the same way that it took Mercury forever to just go through one rotation and have the sun rise and set, it takes even longer for that to happen on Venus. 1 day is actually longer than 1 year on Venus. So you're going to turn like 9 days old before you turn 9 years old. So it actually, the sun rises and sets a full day with the sun going up, coming down, and getting back to that same location. Venus goes all the way around the sun before that happens once. Yeah. In terms of these, just know that it's the second planet from the sun. If you feel you need to write that down, feel free. Otherwise, it's pretty easy to remember. We got Mercury and we got Venus. Does anybody know the acronym that a lot of times people use in order to remember the order of the planets?
Something about
Because the one I use is usually different from the one that I hear from students. Does anybody have one that they might remember? That's a good one. Yes.
I very some mother just gave us 9 peaches.
Yeah, something like that. Yeah, mine was my very elderly mother just served us 9 pizzas. Yeah. So, second planet from the sun. One thing that's kind of interesting to take note of is look at how fast this is going around the sun. 21 miles per second. And if you remember it all from Mercury, it was about 30 miles per second. So when we're orbiting the sun, going around and around and around, we're not just lollygagging it through space here. We are booking it. A little bit about the size of Venus. It's pretty close to the Earth. Do the percentage. Write the percentage down. As long as you remember that it's about the size of Earth, you should be okay, though. And so it's pretty easy to tell why people thought that, maybe Venus is a lot like Earth. It's about the same size. It's not that much closer to the sun than we are. So how different could we possibly be? In terms of volume, as you would probably guess, you could only fit one Venus into the Earth. So you don't have to write this down. Average density is about 5, which is roughly the same as Earth too. So density-wise, we're about the same too. One of the biggest differences, though, is temperature. So we got to see what you guys think the temperature on Venus is going to be. If you remember, Mercury was 801, I think, right? All right, so how hot do you think it gets on Venus?
1,000.
You're hearing 1,000? 1,100? Other guesses? 1,200? Perhaps 802, just a little bit above Mercury. The temperature during the day on Venus that you need to write down is a balmy 864 degrees Fahrenheit. And so this is almost precisely twice your frozen pizza cooking temperature. Any guesses on what it is at nighttime? Mercury was negative 300 something. Negative 400. Negative 20. It's maybe not as cold.
Yeah, so about maybe 500, 600.
Maybe 500 or 600 degrees? Negative 500 or 600.
Not negative.
Is 880.
Okay. So maybe just regular 500 or so. Okay. All right. The temperature at night on the surface of Venus is 864. Wow.
That's what I'm telling you.
Because it spins so slow.
Good guess, but no.
It's the carbon. It's because it's hot.
That's true.
Yeah, that's what I was
Absolutely.
trying to tell you.
So it's 864 degrees. The reason that we do not get a change in temperature on Venus's surface is because it has an extremely thick atmosphere. Go ahead and write down extremely thick atmosphere. So kind of the same analogy that I use for Earth, where if it's a clear day, you're going to notice a big temperature difference between day and night because all that heat is free to escape. Venus is the exact opposite. That heat is not allowed to leave because the atmosphere is so darn thick. And that's known as the greenhouse effect. You've probably heard of that before. Heat comes in, and it's so thick that it just can't leave. It's stable on the surface at that temperature, whether it's day or whether it's night. In addition to that interesting thing about the surface, some of the other aspects of the surface atmosphere is this. Go ahead and locate this on your handout. So if you landed on Venus, you'd experience 92 times the pressure that you would experience on Earth's surface. In other words, it would be like transporting yourself to a mile underwater. You're not going to survive too long. So then the question is, what kills you first, the temperature or the pressure? We'll find that out in a little while. But go ahead and put a little star or circle this right here. The surface atmosphere is extremely thick carbon dioxide, or CO2. And then right above this, or actually it might be easier just to write it like this, put a little dash after surface atmosphere and write down greenhouse effect, just so that you remember that's why it's so hot.
So just the extreme thick CO2.
Yep.
And then the greenhouse.
That's right, yep. So you've got wind speeds of 2 to 3 miles per hour, which really doesn't seem like that much, but if you're experiencing the same pressure you would feel 1 mile underwater, those wind speeds of 2 to 3 miles an hour, it'd be awfully hard for you to stay in one place. Sulfuric acid rain in the upper atmosphere, this does not make it all the way down to the surface, but it does happen higher up in the clouds. So if you ended up getting up there or on your way into Venus, you would experience all that sulfuric acid rain and strong lightning storms, so at least you'd see some pretty cool lightning for the second or two that you're conscious on the surface of Venus. Now here's something that's interesting. I just got done telling you guys that the day side and the night side on Venus are the same temperature. But here we see a picture that's, it tells you basically it's a thermal image. So the hotter it is, it's more red and orange, and the cooler it is, it's blue. How is it possible that what I told you could be true, and yet when we look at this picture, we see different colors when we look at Venus from a distance? It's not the actual ground. What do you suppose it is? Yeah. So this is a picture that was taken with thermal imaging from, a distance away from Venus. So you're looking at the planet from, I don't know, maybe 600 or 1,000 miles away. And you take that picture and this is what shows up. Obviously the sun is going to be down here and it's heating up the cloud tops. But just because the cloud tops are hotter here than here doesn't mean it's going to be a temperature difference on the actual surface. That's why it looks this way. In terms of other things about this slide, Venus does have a double atmospheric vortex, which is kind of an interesting thing. I will have you not write that down, but it's kind of neat to have it in the back of your mind. If you're looking at Venus, you can see it's swirling around the pole here, and this is a zoomed-in picture of that. It makes like a little figure 8. So you've got some crazy atmospheric stuff going on at the poles. In addition to that, one thing we do want to talk a little bit about on the clouds of Venus is You guys heard about the life that was found in Venus's clouds? I've had a couple students bring that up to me about how they think they found life hanging out in the clouds of Venus. And so that's the sort of thing that you see in the news reports, and they say how life is probably existing inside Venus's clouds. Let me just shed a little bit of light on that for you. What they found inside the clouds of Venus is something called, I think it's phosphine. Phosphine, it's something like that. It's a gas, and it's a toxic gas, and it's the sort of thing that some bacteria on Earth excrete while they're alive. So because they found that gas, they assumed that there might be life there, but what they just found was the gas. They didn't find the life. And that's one of the sad things about science, is that oftentimes you'll see these headlines and they really grab your attention. You know, there's life in the clouds of Venus, but in reality there probably isn't. I've heard stories like this over and over again, whether it's the exoplanets from 2 years ago that were supposedly just like Earth, or whether it's supposed bacteria on Mars, or whether it's a UFO following a comet. There's always a tendency for people to sensationalize the possibility of there being life out there, when in reality what ends up happening is the story grabs all these headlines and they never print the retraction later. So people just kind of are led on to believe that. I'll believe it when I see it, if they can find some life in Venus's clouds, but I would bet just about anything that they're not going to find it. They found a gas there. I mean, we know that there's carbon dioxide on the surface of Venus, but we know there's no plants there. We know there's no humans there, even though that's a gas that's necessary for us. But anyway, it would be kind of neat, though, to try and just get rid of all these clouds to see what the actual surface looks like from this distance, wouldn't it? So let's go ahead and get rid of those clouds. All right, here we go. So, thank you.
I should have got you a camera.
If we blew all the clouds away from Venus, this is what it would look like. I should have inhaled. I should have been over there inhaling it. Yeah. So, Venus is kind of a butt ugly planet, isn't it? Might be best we just leave those clouds on. But this is the sort of thing you'd see if you did get rid of all those clouds. It's not going to look like anything fancy, but you will notice some changes in elevation here. All right. If we did get rid of all those clouds and we could see the sun from Venus, because there's no way you're going to see it with all those thick clouds, compared with Earth, the sun would look this much bigger than it looks on Earth. So not huge like it would be on Mercury, but still pretty big. Now, just like Mercury, Venus is closer to the sun than we are. So the only time that you're going to see Venus is at dawn or dusk, and the reason for that is because it's just following the sun. So it's always going to be near the sun, because it's much closer to it than we are. You can go ahead and write this down as well. Nah. As long as you know it can just come up at dawn or dusk, that should be enough. You probably did. If you guys are, Venus is up in the mornings right now. So on your way to school or whenever you get up, take a peek outside. If you see an extremely bright star, that is Venus. It is an extremely bright star. And compared with regular stars, this is how bright it looks. Go ahead and just write down the last bullet point here. It's the brightest thing in the sky aside from the sun and moon. Oh, you have this one? Oh, this is in your history class? Oh, cool.
No, in the history part, like the first line that you showed.
Oh, so that's already in your notes.
Yeah.
Oh, good. Well, then you don't have to write it down. But yeah, Venus is a very, very bright star. oftentimes, when people report UFOs, 25% of the time, Venus is the result. They have seen actually Venus, and it looks so bright that people think they're seeing a UFO. UFOs are something we'll talk about later on this semester, too. You don't have to write anything down here, but a couple interesting things about Venus. If you do look at it through a telescope, this is the sort of thing you'll see. It's very difficult to see the clouds on it unless you have a good filter. But if you do have one, you could see some of those patterns. And just like Mercury, because it's closer to the sun than the Earth, it will go through phases just like the moon does. And you can see here, the left half is lit, which means it's in the, what phase is that from the moon? The left half is lit, you remember? I think it's the third, yeah. Third quarter. What does the sky look like on Venus? Go ahead and write down what it looks like during the day. It looks orange-red. Yep, just the day. And yeah, this is a pretty good picture of what you would see if you landed on Venus and opened your eyes for a second or two. In terms of gravity, as you'd probably expect, the gravity on Venus is going to be roughly the same as the Earth. You can skip that. 1.1 times your jump height on Earth. So if you did land there and you didn't have a spacesuit on, you'd probably be able to jump about as high as here. By the time you landed, you'd be dead, though. Geological activity, you can write that it's active. There are lots of active volcanoes on Venus. And this is an image taken directly above one of these very geologically active locations. In terms of the composition here, it's about the same as the Earth's. Just like us, we've got a rocky crust. Just like us, we've got kind of a viscous liquid rock mantle, and the core is metal, pressurized. It's metal because it's so pressurized it's able to hold that solid shape. All right, a little bit about the magnetic field on Venus here. You can see Earth. This is Earth right here. We've got a magnetic field. So the sun, when it blasts off all of its radiation, we call it the solar wind. Solar wind kind of makes it sound like a gentle, warm breeze, but it's anything other than that. It's very deadly radiation. And because we have this magnetic field, it deflects a lot of that radiation around us. The spots where it does make it through, we can see the northern lights. But overall, we're very well protected. Venus, though, not so much. It's pretty much just getting annihilated by that solar wind there. And so what that means is that Venus doesn't have very much of a magnetic field. This is on your handout. Go ahead and put a little arrow next to the second bullet point. The magnetic field that Venus has is only there because it has ions in its atmosphere. And when those ions interact with the ions coming in from the sun, from the solar wind, it creates a magnetic field as just a little byproduct. It's not very strong. It would not protect you if you were there. And if the sun disappeared, so would Venus's magnetic field. You can do this one too. Write that down. That's kind of interesting. So we've got a small amount of water vapor in the clouds, and it's in a very, very small area. because the further out you get from Venus, the colder it's going to be. The higher up you are on the cloud tops, the colder it's going to be, and eventually that water would freeze. And as you descend, it's obviously going to get warmer and warmer. So it's in a very particular location where that water can actually exist as vapor. If you land on Venus, a couple things would happen here. Basically, you'll be burned alive, with or without a spacesuit. You can write this down. Just do the whole thing. You got yourself a fire blanket, you might get burned alive maybe just a half second later. Yeah. Sure. That would be nice if you could just drop a pizza through Venus and it would arrive on the surface made. I think our goal in this class is to bring up frozen pizza somehow for every planet. So in the race to kill you, between pressure and temperature, the temperature is going to get you first.
Faster or slower than a microwave?
Oh, you'd die much faster here than a microwave. You're in a microwave, you'd live long enough to enjoy it.
Why would you need a microwave?
All right. So Venus, when we look at it, goes against the most popular theory of solar system formation. If you go along with the idea of the Big Bang and all this stuff happened by a swirling cloud of gas, then you have to believe in the nebular hypothesis. Go ahead and write this down, and I'll talk a bit more about that in just a second. And so the reason that this goes against the idea that planets form naturalistically on their own through a swirling gas cloud is because if that happened, then, angular momentum must be conserved. What that means is everything ought to be spinning the exact same way. And if it's not, there's something seriously wrong. Well, Venus is just spinning the wrong way. So there's no easy solution to that. It goes completely against the idea that all of the planets in our solar system formed as a result of a collapsing, swirling gas cloud. And even so, the alternative might be, well, maybe Venus was traveling through outer space and it just got captured by the sun's gravity. Well, if that's true, then how is it that it's happened to be aligned in the orbit exactly with the disk of all the other planets of our solar system? It's almost as though it was designed this way. But of course, we can't go there in the scientific community. So this is on your handout. Just a couple things to just look at briefly here. It does rotate in the opposite direction, which means that if you were there and the clouds are blown away by me, you would see the sun rise in the west and set in the east. It possesses a whole bunch of big volcanoes that are 62 miles or across. We've only got one, and that's Hawaii. Space probes don't need parachutes to land, and the reason for that is because the atmosphere is just so thick that it will slow them down enough that by the time it reaches the ground, it's not traveling very fast. And if there is no moon out, and Venus is the only thing out at nighttime, it's actually bright enough that it can cast shadows. So it is a very bright thing in the sky. Go ahead and write down what it comes in first place for. And so again, I want to just say one more thing, and that's, again, with the whole idea of the nebular hypothesis, because Venus is spinning the wrong way, it cannot have resulted from the same collapsing gas dust cloud. So if it did somehow get captured and just end up in that perfect location in the solar system, here's something else that goes against that idea. It has the least eccentric orbit of all the planets in the solar system. So what that means is that as it goes around the sun, it does so in almost a very exact, perfect circle. More perfect than any other planet. Longest day, hottest planet out there. You don't have to write any of these down, but it comes in second place for a couple things. Second closest to the sun, second largest orbital speed, second shortest year. No surprise there. So we'll go ahead and have a little quiz on Venus when you come back on Monday. I don't know. We'll see.